Okay. So remember, for this chapter, you want 2 equations. 1 equations will do you no good. You need 2 equations to solve for 2 unknowns. So in this case, let's come up with our 2 equations. Before I start the equation, what do I need to do? Before I create any type of equation? Let statement. I have to define my variables. So let. Okay, what do you think a letter makes sense for this situation?
You could use C for carnation and R for roses.
Yeah, C for carnations and R for roses. Yep.
I said we use like X and Y or something.
Yeah, that's fine.
That's fine.
Yeah, but just say like let X be carnation and then Y be rose. That's why it's important to define your variable, especially at the end when you do your therefore statements. You don't have to think back to think, oh, so what is X, right? So right here we have this. Now we can start our equation. First equation. Total of 10 rows. Alright, so the first equation is always the easiest one, is like the number of. It's always like the number of. So in this case, how many, Ryan, how many flowers do we want in total? Now that you have a handout in front of you. And oh, what happened to you?
Oh, she's ripped. She's handing it back.
No, it isn't.
Why is it ripped?
I didn't hear. I'm trying to help it.
Oh.
Oh, Catherine, you need this for the last
Yeah. So, Catherine, you want to take back your rip paper that I just gave you like 2 seconds ago? How does it taste? Sorry. That was funny though. Okay, so Ryan, since we have 10 flowers in total, how would we write our first equation? Yeah?
R plus 4. Wait, no. R plus 6.
No, just the total. Just a total of 10 flowers.
R plus C equals 10.
Yeah, yeah. So see, so Ryan said R plus C equals 10. Yeah, that's it. First equation is just straightforward number of. Second equation is usually the trickier one. So this one, 4 times as many carnation as rose. Sometimes you have to read it a few times to actually make it make sense in your head. I sometimes mix them up too. So here's that little trick. When you read this, which one has more, carnations or rose? Carnations. So do C equal. Okay. So that's like a little trick that you can use if you want. And so if I have 4 times as many, my equation is just going to be C equals, Kelly? R. Yeah. Okay. I know my classes in the past struggled with, is it R equals 4C or C equals 4R? So just think which one has the more. That's the equal. Okay. Good. So for this one, so now let's label our. So this means this is going to be C. We're going to say carnation is down here. Carnation. And we're going to do rose as our Y. Okay, since we're doing this by graphing, let's graph this. So Y equals mx plus b. So if we were to rearrange this equation, we would have R equal negative C plus 10, right? By rearranging the first equation. Yeah. Okay. What's my y-intercept here for the first equation, Paul?
10.
10. So I'm going to plot my first point right here at 10. And what's my slope? R equals negative C plus 10 is the same as Y equals negative X plus 10. So my slope here is, Paul, do you want to finish up this line for me?
Negative 1.
Negative 1. So down 1 over 1. Down 1 over 1. Okay, I know I'm skipping like 2 boxes. That's because I have to go by the scale, not always by the number of box. Okay, so going down 1 over 1, down 1 over 1, down 1 over 1. Just draw a couple of these so that it's nice and long. My line is long enough. Okay. Alright. And the second line, C equals 4R. What's my y-intercept here for my second line? C equals 4R. My y-intercept is? Yep. 0. Right. So right here. And what's my slope? Yep. 4. So up 4 over 1. Up 4 over 1. Up 4 over 1. And there's my second line. Okay, so this is equation 2. This is equation 1. Yep.
How do you know the slope is 4?
Oh, because 4R.
But
This is the same as writing it as y equals 4x. So then you know that your slope is 4 over 1 and your y-intercept is 0.
wait, isn't C X and R Y?
C is x,
But
R is y.
if you like move
Oops.
by 4, like it's 1 over 4 C
Oh
equals
yeah,
R.
oops, I made a mistake. Good catch.
If you were gonna set it, if you can like reverse it.
Yeah. I think that's the easiest way.
So you like turn the graph that you did then like
I think easiest way is okay. So if so why don't we set C as the y? C as the y. So this equation I have to change as well. It's actually the same when I rewrite this. Okay, so if I set C is the y, so this is carnation. My bad. And then this is rose. So here I want to isolate the C instead then. Negative R plus 10. So your equation was the same, but the variable, I mixed it up. Good catch, Paul. Okay. If I did the other way around, it would just make it 1 over 4 instead, and then your graph would be flipped. Okay, so we have our point of intersection. We have this, what is my POI? What's my point of intersection? Wow. It's a Thursday morning, isn't it? Junha? 2 and 8. Okay, what is the 2? What is the 8? Yeah. Good. And 8 carnations. Okay, I know it's 2 rows because this is my x value. On my x-axis, I said that rose is my x. So I know it's roses. So my y is carnation. And also remember the question at the beginning says I want 4 times as many carnations. So the bigger number should be the carnation one. Okay. So therefore, Sarah is going to make a bouquet using 2 rows and 8 carnations. So first method, we solved it using graphing. Any question on number 1? Oh, okay. Okay, number 2 on the back. 2 cartons of milk contain different percent of butterfat. How much 1% milk needs to be mixed with 5% milk to give 10 liters of 4% milk? Okay, so I see some numbers here. I see the 4%. the 1%, the 5%, the 4%, and I see the 10 liters. All right. Again, how many equations do we want to make? 2. First equation is always the amount, the number of. Okay. So, actually, let me back up. Let statement. Let's do x and y. Okay, so that we don't mix up our x and y again. Okay, let x be. What are my two types of thing right here?
5% milk and 1%.
Right, so let x be the 1% milk, and let y be the 5% milk. Okay. So, it's not just enough to just say milk because you have two different types. Okay, so you have to make it nice and clear. So now we write our first equation. First equation is always the number of, amount. How much? Yep.
X plus y equals 10.
Yeah, x plus y equals 10. Because that's the amount I want. 10 liters. So 1% milk plus 5% milk give me 10 liters of milk. Second equation is the tricky one. Second equation deals with what I highlighted, these info. Okay, who wants to give it a try? Yeah. Ariane?
Y plus x equal to 4.
Close, but whenever we have percentage, thanks for trying. Whenever we have percentage, what do we have to do with that percent?
Convert it to decimal.
Convert it to decimal. So I'm going to have 0.01 times x. Alright, I should be more specific right here. It should be amount of 1% milk. So when we define this is like actually the amount of 1% milk and amount of 5% milk. So 1% times the amount of that 1% milk plus 5% times that amount of 5% milk equal. Here's the tricky part. What does it equal? Right?
0.04 times 10.
Excellent. 4% times that amount of milk. And do we know how much of 4% milk we want? 10. So we actually know this amount. A lot of people just write this or write this, but you actually have to multiply. And if you look at it, it's consistency. Percentage times amount, percentage times amount, percentage times amount. Yeah. Okay. But we hate decimals. We don't like decimals. Is there a way that we could multiply this to get rid of the decimals, Kelly?
Multiply both of it.
Yeah, multiply everything by 100. So this becomes x plus 5y equal? Well, let's take a look. Remember, we're timesing everything by 100. So 0.04 times 10 first. We get 0.4. And then times it by 100, you get 40. All right, so that's where 40 came from. When you times this, you got 0.4. Times it by 100, that's how you get that 40. Because when you times by 100, you have to times it to both sides. Okay, so now my equation looks a lot nicer. Okay, I have these two equations to work with. Let's use the method of substitution. Okay. Okay, so substitution, let's rearrange this equation to x equal. So this becomes negative 5y plus 40. Okay, and now I'm going to sub in this equation into equation 1. So sub x equals negative 5y plus 40 into equation 1. So we get negative 5y plus 40 plus y equals 10. Okay. Simplify the x, move over the y. Simplify the y's and move over the number. So negative 5y plus y, you get negative 4y. 10 minus 40, you get negative 30. When you divide that by negative 4, you get 7.5. Now let's say I made a mistake and I got negative 7.5. Does that make sense if I get a negative number? Why not? Right? Yeah, but let's say I just missed the sign. I missed it and I just divide negative 30 by 4. I got negative 7.5. How do I know that doesn't make sense?
Well, you can't really have like negative milk cartons. So
Right. I can't have negative amount of milk. So, and so what is my unit right here? What's my unit for y? Yeah, liters. Yeah. So y is 7.5 liters. And now that I have y, I'm going to substitute y equals 7.5 into this equation right here. Into this equation. So x equals negative 5 times 7.5 plus 40. And negative 5 times 7.5 plus 40, I get 2.5 liters. Okay. Now, if you look at the big picture, the overall question, so this was the simple method, like just plugging this into the equation, we get that x is 2.5. Logically, without doing this part, how do I know how many liters of is x? Exactly, right. You need 10 liters in total, so that means that if your math is good, you need 2.5 liters. But this way helps you check your answer so that you know you did it correctly. They add up to 10. I feel confident about this answer.
To ask a question like this, do you want us to check it as well, or could we just
If I say check your answer, show your check like that, then yes. Otherwise, it won't be for marks, just to make you feel good. Okay, so you don't have to check, but if it says in the question, part of the question, then you do. Okay, last example. Ian, he likes canoeing, and he's canoes 20 kilometers downstream in 5 hours. On the return trip, it takes him 8 hours to travel 16 kilometers. Determine his average canoeing speed and the speed of the current. Okay, so these type of speed, current, these type of questions, easiest way to do these is doing a table. So upstream, downstream. What's the difference between upstream and downstream? What about it? Yeah, Alan?
when the current is working with you, when the current is going against you?
Yeah, so which is faster? Downstream. Yeah.
These are a similar problem from the homework as well.
Yes.
I just did.
Okay. Distance. Time. Speed. Okay. So these type of question, I think it's the easiest when you have it set up in a table. Okay, so let's define our variable again. I always jump ahead of myself. I like to do the table first, and then I'm like, oh wait, I need to define my variables before I can make equations. So let's do some. What are my two variables right here? Yep.
The time and the distance.
So you want to refer to your last sentence, the question. That's your hint of what your variable should be. Okay. So what are my for example right here, my x is the amount of 1% milk, the y is the 5% milk. In this case, I want to find the two different
The canoeing speed and the speed of current.
right, the two different speeds. So let they're both C. So let's do P for paddling speed or canoeing speed. Same thing. Paddling. Just like this. Is that how you spell paddling?
Yes.
Paddling. Okay. Let P represent paddling speed. And let C represent current speed. Okay, so you can see why I did use C and C. I didn't use canoeing because they're both C. Okay. So for upstream, going upstream, what was the distance going upstream? Yep. 16 kilometers. Good. The time? Yep. 8 hours. Okay. And the speed. Since I'm going upstream, I have my paddling speed. But since I'm going upstream, what do I have to do with my paddling speed? I'm going against the current. What does the current do to you? Slows you down. So my paddling speed slows me down, which means I should minus. So I have to use paddling speed minus the current speed. Okay. Similarly, downstream is 20 kilometers. It takes me 5 hours. And what will my speed be for going downstream? Yep. P plus C. Good. Because the current is in my favor. Okay.
Can you just calculate speed based on distance and time?
Yeah, that's exactly what we're going to do next. Okay, so now we need to make a connection between all of this. We have to come up with our equations. So those who are good at science knows this triangle. Have you guys seen this triangle in science?
Yes. TV.
Yeah. DST. We call it DST. Yeah, distance, speed, and time. So this is how you use this triangle. If you cover up speed is distance divided by time. To find distance, you do speed times time. If you want to find time, you do distance divided by speed. Okay, so let's do D equals ST. Distance equals speed times time. Let's use this formula. So to build our first equation for upstream, how would you set this up if I know the formula now? Ryan?
20 is equal
For upstream, let's do the first row first.
16 is equal to P minus C times 8.
Yeah, perfect. Okay, I'm just going to rewrite it like this because we're used to seeing it this format. Okay, and my second equation. Yep.
20 is equal to 5 equals
Perfect. Okay. Yep.
What was the reason that you arranged it like that? The equal
Instead of the other way.
yeah.
We're just used to seeing this way more, And when you write it like this, you know to distribute. Because when you write it the other way, people miss the distribution. Yeah. All right. So we have our equation set up, but it's not the prettiest. So let's expand this out. So 16 equals 8p minus 8c. And this one, when we distribute it out, we get 20 equals 5p plus 5c. Okay. So, since yesterday's homework was on elimination, let's use the method of elimination for the sake of our practice. Okay. None of the coefficients match up. So we need to force it. We need to multiply both equation by something. So, which letter do you guys want to eliminate? The P or the C? P? All right. So let's try to eliminate our P value. So I'm going to multiply this equation by 5. And I'm going to multiply this equation by 8 to get the 40p that we need. So the first equation, and when I multiply everything by 5, I get 16 times 5, which is 80, equal 40p, whoops, minus 40c. Second equation, I'm going to multiply everything by, oops, sorry. Don't restart yet. It's not letting me press snooze.
We have 59 minutes.
Yeah, okay, so it's enough time for, I'll be done this example in 2 minutes, so I'll move it up. Right here, 20 times 8, 160, equal 5 times 8, 40p, 5 times 8 plus 40c. Yeah, okay. Yep, okay. So, as Ariane said, we want to get rid of the p's. So, should I add or subtract to get rid of p? Subtract. Alright, that's process of elimination. I want to subtract it to get rid of the p's. Okay, 80 minus 160. 80 minus 160, you get negative 80. 40p minus 40p, that's gone. Here's the tricky part. Negative 40c minus 40c. What's that? Negative 80c. Okay, so when you first write it, you might be thinking, doesn't everything cancel out? No, because the signs are different. So when you do subtract it, they don't cancel out. This doesn't cancel out, only this. So when you divide it out, what is C? 1 what? What's my unit? Yep. Sorry? km per hour, kilometers per hour. And how do I know it's kilometer per hour and not meters per second?
Because the other units are
Right. If you go back to your table, that's the units we've been always using. So we have the current speed. So now to substitute that into one of these equations, we can substitute it in. So sub C equals 1 into, let's say, equation 1. Okay. So 16 equals 8p minus 8 times 1. So you get 8 equals 8p. Is that right? Did I do something wrong? Oh, no. 24, yeah. Okay, when you move this over, 16 plus 8 is 24. Yeah. So then when you divide it, P equals 3 what? Kilometers per hour. Okay, so this was one of the trickier word problems. But now that we did it together, does it make sense? Yeah, so I think the key was like setting this table up. Whenever you deal with like speed and time, distance type of questions, remember this, like set it up like this. It will help organize your equations much neater, much easier. Okay, because this formula, I just used the distance equals speed times time formula. You could have went above and beyond and set up your equations using speed instead, or you can set up your equation using time instead. You'll end up coming with the same answers. I just chose D equals S times C because I didn't want to deal with fractions. I didn't want to deal with yeah. So this way, there's no fractions, nice and easy to understand, and we found out the 2 speed. Okay? Any other questions? Okay, so that's all I need to teach you for this chapter. Tomorrow we'll do review. Monday we do review. Tuesday is the actual test. Tuesday test, yes. You sound so surprised. Alright, these questions, bright space. It's on bright space. On bright space. Let me see. This one, content, chapter 2. Chapter 1. And then linear system word problems. Makes sense, right? We work on word problem today. It's this one. So when you scroll down to page 3, you'll see the questions and you'll see the answers. Okay. I'll let you guys work on it for a bit first, and then I'll give your test back. From the test, people did really well on the test. I think the only tricky part was the word problems. So you know that you need the practice on word problems, and that's why there's a whole bunch right here for you guys. Okay, so make sure you try these.